Hello and welcome to Genesis Training. This is your trainer Kaustav. The topic for the day is numbers and the subtopic is power cycles. So let's get started. Let me first talk about the concept of power cycles. The first digit that we'll be talking about is 2. This is the power cycle of 2. Now why is it called a power cycle? It's because 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16 and 16 ends with 6. So we only care about the units places over here. So this is about powers. Why cycle? That is because this keeps on repeating. 2486, 2486, 2486. Let's see. 2 power 5 is 32. 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. After that, 512, 1024, 2048, 4096, 8192, so on and so forth. So this goes on and on and on. 2486, 2486, 2486, 2486. This is why it's called as a power cycle. The next such digit is 3. 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27, so we have 7 over here, and 3 power 4 is 81, so we have a 1 over here. The next such digit is 7. 7 power 1 is 7, 7 power 2 is 49, so we have a 9 over here. 7 power 3 is 343, so we have a 3. 7 power 4, not a lot of people know this, but the thing is you don't need to. You do not need to know what is 7 power 4. I'll tell you a very small trick to write down the power cycle every single time. It's very simple. Let's consider 3. 3 into 3 is 9. Alright. 9 into 3 is 27. Done. 7 into 3 is 21. So we have a 1 over here. Now you and I know that this 1 actually came from 81 because 3 power 4 is 81. But whether the 1 comes from 81 or the 1 comes from 21, 1 is 1 and that is all that we care about. Similarly over here, 7 sevens are 49, so we have a 9 over here. 9 sevens are 63, so we have a 3. Again, you and I know that this 3 is actually from 343, which is 7 cube. But whether the 3 comes from 63 or the 3 comes from 343, 3 is 3. So after that we have 3 into 7, that is equal to 21. That's it. The next such digit is 8. 8426. Again, 8 8s are 64, 4 8s are 32. This 2 is actually from 512 because 8 cube is 512. But whether the 2 comes from 512 or 32, 2 is 2. And after that we have 6. 2 8s are 16, so 6. The good news is these are the only 4 digits with the power cycle of 4 terms. After that we have 4 whose power cycle just consists of 4 and 6 because 4 4s are 16, 4 6s are 24. 4 4s are 16, 4 6s are 24. 4 4s are 16, 4 6s are 24. That's it. And the other digit who has a power cycle of 2 terms is 9. 9 9s are 81, 9 1s are 9. 9 9s are 81, 9 1s are 9. That's it. So the best part about 4 and 9 is this. 4 to the power odd number will always end with 4. 4 to the power even number will always end with 6. 9 to the power odd number will always end with 9. 9 to the power even number will always end with 1. Okay, so for example, 9 to the power 1, 2, 3, 4, 5 will definitely end with a 9. And 9 to the power 1, 2, 3, 4 will definitely end with a 1. That's it. Now, the best sets of digits when it comes to power cycles is 0, 1, 5, 6 because they always end with 0, 1, 5, 6 no matter what the power is. Because 0 and 1 is very obvious, 5 5s are 25, 5 5s are 25, 5 5s are 25, 6 6 are 36, 6 6 are 36, always. So these are the power cycles. Alright. Now when it comes to units places, generally speaking, without the power cycles, it goes like this. Suppose I'll give you a very simple example. 123 into 456 into 789. What is the units place of this product? You can grab your calculator and get the answer. I think you'll get a 9 or 10 digit number, but we only care about the units place. So all we have to do is the units place over here, we have to multiply. So 3 into 6 into 9. 3 6 are 18, that ends with 8, and then 9. 9 8s are 72, so that ends with 2. So no matter what product you get, I am 100% sure it will end with a 2. Similarly, if this was plus, then we would have to plus these, add these. That's it. This one's the concept. Now let's start with the questions. Question number 1. What is the last digit of the following expressions? I have designed these questions in such a way that you understand the concept of power cycles step by step. So the first thing you always do is you write down the power cycle of the digit. So we have 2 over here. 2's power cycle includes 2, 4, 8 and 6. Okay. 2 to the power 5, we all know that 2 to the power 5 is 32. So that will definitely end with a 2. Now 2 to the power 25. One thing we can do is we can count till 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. So again we have 2 as the answer. But obviously this is not a very nice way to do it, because what if you have 125 in the power? Then what to do? Would you actually count till 125? Absolutely not. Then what do? This 2's power cycle has 4 terms. That means it is mod 4. That means after every 4 terms, the cycle repeats itself. After every 4 terms, the cycle repeats itself. So what we do is we divide 125 by 4 and we see how many terms are remaining. What is the remainder? And that will be the power of 2. For example, 2 to the power 125 we have. So 125 by 4. What is the remainder of 125 by 4? It is 1. That means 2 to the power 125 can be written as 2 to the power 1, that is equal to 2 itself. This means till 124 the cycle was complete. After that we had one more over here. That's it. Okay, the same thing applies over here also. 25 by 4, the remainder is 1. So again 2 to the power 1, that is 2. That is the answer. Now let's talk about this. This is the main question over here. 432 to the power 1, 2, 3, 4. Okay. So we have, first of all, how to simplify this. We don't care about the 43 over here. 43 we don't care because we only care about the units place. So we have 2 to the power 1, 2, 3, 4. And if you know the divisibility rule of 4, then this can be even simpler. What is the divisibility rule of 4? It states that if the last 2 digits of the number is divisible by 4, then the whole number is divisible by 4. Okay, so we only care about the last 2 digits over here because we are ultimately dividing by 4. So we don't care about the other digits. So this can be further simplified to be 2 to the power 34. Now all we have to do is 34 divided by 4. What is the remainder? The remainder is 2. That means the answer is 2 to the power 2, that is 4. That is the answer. So how did we reduce this? First 432 to the power 1, 2, 3, 4 got reduced to 2 to the power 1, 2, 3, 4. 2 to the power 1, 2, 3, 4 got reduced to 2 to the power 3, 4. And that ultimately got reduced to 2 to the power 2. That is 4. Alright. Let's move on to the next question. What is the last digit of the expression 777 to the power 777? Let's simplify this again. 777 to the power 777. First simplification, we only care about the units place over here. And yeah, one more thing, we have to write down the power cycle of the units place. We have 7 over here. 7 sevens are 49, 7 nines are 63, 7 threes are 21. So 7931, that is what we have. Okay, so this gets reduced to 7 to the power 777. All right, now this gets further reduced to what? We have to ultimately divide this by 4, right? So we only care about the last 2 digits of the power. So 7 to the power 77. Because 4's divisibility rule states that we only care about the last 2 digits. Now we have 77 by 4. The remainder is 1 because 76 is divisible by 4. So the final answer is 7 to the power 1. That is equal to 7. That is the answer. Answer is C. Let's move on to the next question. Now let's talk about example 3. The units digit of the product, this is what? First of all, let's write the power cycles of each term. 3, power cycle is 3. 3 threes are 9, 3 nines are 27, 3 sevens are 21, and we have 7. 7, 9, 3, 1. Now let's simplify this. 3 to the power 1001, and we know again it has 4 terms, so we have to divide the power by 4, so we only care about the last 2 digits. So 01 multiplied by 7 to the power, again last 2 digits, 02, into we have 3 over here to the power 03. Let's do this. 3 power 1 is nothing but 3, 7 power 2 is nothing but 9, 3 power 3 is nothing but 7, 3 power 3 is 27, 3 nines are 27, into 7, 7 sevens are 49, we have 9. Answer is D. That's it. Let's move on. The units place of the product this and this is what? Okay, this is a very interesting question. We have 34 to the power 123 factorial. Let's simplify this first. We only care about the units digit. So we have 4 to the power 123 factorial into 3, 4, 5, 6 to the power this. Again, units place is 6. 1, 2, 3, 4, 5, 6 factorial. Let's write down their power cycles. 4's power cycle has only 2 terms. We have 4 and we have 6. 6's power cycle is the best power cycle ever. It only has 6. So whenever you have 6 or 5 in the base, the first thing you should do is smile because the answer is already there. So first of all, 6 to the power anything is 6. So we already know the answer to this one. This part is definitely 6. 6 to the power anything is 6. Now 4 to the power, we had talked about this. 4 to the power odd numbers ends with 4. 4 to the power even numbers end with 6. Now 123 factorial is odd or even. A lot of people make this mistake. They think that 123 factorial is an odd number, but it's not. 123 is an odd number, but this is not 123, it is 123 factorial. Always remember one thing, every factorial starting from 2 factorial is an even number because ultimately they all get multiplied with 2. 2 factorial is 2, 3 factorial is 6, 5 factorial is 120, so on and so forth. Every factorial starting from 2 factorial is an even number. The only 2 odd factorials are 1 factorial which is 1 and 0 factorial which is 1 again. Alright, so remember n factorial is even when n is greater than or equal to 2. So 123 factorial again is an even number, 4 to the power even, and 4 to the power even numbers is 6 into 6, that again is 6. That is the answer, D. So there we have it. That was power cycles. A few things you need to remember. First of all, there are only 4 digits with a power cycle of 4 terms. That is 2, 3, 7 and 8. You don't need to remember everything to the power 4. I just taught you how to get the power cycles. Just multiply by the same number, multiply by the same number. That's it. Alright. And after that, if at all the power needs to be divided by 4, all you need to do is divide the last 2 digits by 4. For example, if at all you need to divide 1, 2, 3, 4 by 4 and get the remainder, all you need to do is you need to divide 34 by 4 and then get the remainder, which is 2. 34 by 4 remainder is 2. So 1, 2, 3, 4 by 4 remainder will also be 2. That's it. Thank you so much.